Hello folks, I am here with again another problem. So this problem is also concerned with the chapter of telescope. So the first three words read an astronomical telescope. It's okay. Having an objective of a focal length 50 centimeter, objective focal length 50 centimeter, is focused on the moon. So moon means that the distance is infinite. So though we know the exact distance of the moon from the earth, in optical calculations we take it as infinite for the lens systems. So it means that the object distance is infinite for that particular lens, object lens, and the focal length is 50 centimeter. By what distance should the eyepiece be drawn out? Means it should be moved backward. That means backward to focus on an object at a distance of 50 meters. So initially it was focused for the moon. So the moon is there. It was used to focus on the moon. Now we want to focus that thing on an object which is at distance of 50 meters only. Now for that we have to find by how much distance this eyepiece needs to be drawn out like this, needs to be moved nearer to the eyes like this or towards the observer like this. So we have to find that. So for that let me draw a diagram so to make things understood. So initially this is the eyepiece. This is the objective, let us say. So this is the objective and eyepiece. The rays coming from moon were like this. They were coming parallelly, and they would focus the rays somewhere here. So they will be focusing the rays somewhere here, and this will be seen by the lens here. This will be observed by the eyepiece lens like this. So according to the data, what we have is this f1 is equal to 50 centimeter. So let us first find the image distance. So let us first find this image distance. As is evident from the diagram, what you can say is when the object is at infinity, the image is formed at the focus. So if I do calculations, we can have, so for objective I will have u1 is equal to infinity, because it was used to focus on an object at infinite distance. f1 is equal to 50 centimeter. So that's why I must have v1 also equal to 50 centimeter. It's because we have the equation 1 by f1 equal to 1 by u1 plus 1 by v1 equal to 1 by infinite plus 1 by v1, which gives us 1 by 50 is equal to, this becomes 0 plus 1 by v1 equal to 1 by v1. So this gives us v1 is equal to 50 centimeters. So initially this is 50, and to observe this thing, the eyepiece lens had to be placed like this. Now what they do is the lens is here. It's okay, lens is there. Now this telescope is used to focus on an object which is just at a distance of 50 meters. Just at a distance of 50 meters. So that means now the light rays will be coming somewhat like this. They'll be coming somewhat like this, not parallelly. They'll be coming like this. So they will still be diverging when they reach this lens. So initially they were parallel, but now they come like this. So if so, then they will be focused somewhere here. They'll be focused at a bit larger distance. So you can compare here. Initially it was focused at this distance, but now the distance has slightly increased. So let me draw timeline like thing here. So if I do this, so this is the shift in the image distance, and because of this, what I need to do is I need to draw this lens back. If I have to see this thing, I have to draw this lens back by the same distance. That means by this distance, the lens has to be drawn back by the same distance by which the image has shifted. The first image has shifted. So that's why if it shifts by this distance, the lens also has to shift by this distance. So the lens will be somewhere here now. So this will be the eyepiece lens. So this is the eyepiece lens here, objective here. So this is the shift. This thing will be the shift in the position of the eye, which we have to find this. So this distance and this should be same. It's because the lens has to be shifted by the same distance equal to the shift in the distance of the first image. So if I find this, I can find this. So let's find this. So for that, we need to find the final image distance. So final image distance from here to here. So that requires here. For the second case, I have u1 is equal to 50 meters, because now the object is placed at a distance of 50 meters. That's equal to 5,000 centimeters, 5,000 cm. f1 is still equal to 50 cm. So from there, I will have this v1 is equal to u1 f1 divided u1 minus f1. So let me have a sip of tea. So this is the formula. So it will give me u1 is equal to 5,000 into f1 is 50, and this is 5,000 minus 50. So the answer will be, if I do this, the answer will be like this. Let me calculate. So 5,000 into 50 equal to divided 5,000 minus 50 equal to, so it is 50.5 equal to 50.5 centimeters. So the image now is, initially it was 50, now it is 50.5 centimeters. So that means the shift in the image is, so now this gives me the shift in this image will be, so let me write here. So shift in the position of image will be equal to 50.5 minus 50 equal to 0.5 centimeters. So this image shifts by 0.5 centimeter, and the shift in the lens also should be equal to, so therefore shift in position of lens, position of eyepiece should also be equal to 0.5 centimeters. So this is the answer for this question. So lens has to be shifted by 0.5 cm towards the eyes or towards the observer, so as to see the image of that object clearer.